Yes, how are you doing, guys? It's still Mr. Richard. We are at 1.3. Yes, for those of you who are doing MIP 1502, this video is specifically for you. MIP 1502 is a module in UNISA, specifically for those who are doing intermediate phase, right? So the rows below shows a set of consecutive odd numbers and their totals. Right, we are given that row 1 has 1 is 1, and row 2 has 3 plus 5, and row 3 has 7 plus 9 plus 11, 13 plus 15 plus 17 plus 19. We need to ask ourselves, how did they came up with 3? They added by 2. 1 plus 2, that's 3. 3 plus 2, that's 5. 5 plus 2, that's 7. 7 plus 2, that's 9. And 9 plus 2, that's 11. And 11 plus 2, that's 13. 13 plus 2, that is 15. And 15 plus 2, that is 17. 17 plus 2, that's 19. Then 19 plus 2, that will be 21. So that will be the row 5 now. We are at 1.3.1. Row 5 will be 21 plus 2, that's 23, plus 2, that's 25, plus 2, that will be 27. How many? 1, 2, 3, 4, 5. We had 1, 2, 3, 4. Then lastly, since they said in row 5 we should have 5 numbers, it will be 29, because 27 plus 2, that's 29. Right, then let's look at row 6. That's 4 marks question. 29 plus 2, that will be 30. That will be 31, right? That will be 31. 31 plus 2, that will be 33. Plus 2, that will be 35. Plus 2, that will be 37. Plus 2, that will be 39. Plus 2, 40, 41. Yes, so we have 6 numbers at row 6. So that's how it will end there. Then we have a question at 1.3.2. What is the special name given to the numbers in the sum column? All right. How can we find the special name? The special name for this pattern, you may recall that it starts at 1 plus 3 plus 5 plus 7. So this is a series because of the summation. It's a series. Why I say it's a series? It has a constant difference here. 3 minus 1 is 2. 5 minus 3 is 2. So it's a series. So the special name will be an arithmetic. It will be an arithmetic series. That's the special name for this pattern. Okay, let's go to 1.3.3. At 1.3.3, they said, write down in terms of n how many consecutive odd numbers there are in row n. It's also 1 mark, so that's quite easy. So in row n, we are going to have n times 1, so which is there will be n terms, right? So let's go to 1.3.4. At 1.3.4, they are saying write down in terms of n the sum of the numbers derived in 1.3. So the sum of this of an arithmetic series will be Sn n all over 2, which is 2a plus n minus 1d. So this is the sum, right? Then let's go to 1.3.5. At 1.3.5, they said find an expression in terms of n that calculated the first number in row n. Okay, let's take the original pattern: 1 plus 3 plus 5 plus 7 and blah blah blah. We need to find a general term since they said find an expression or formula. So the first term, it's a, and the difference will be 2, because 1 minus 3, it's 2. 3 minus 1, I mean it's 2, so it's going to be 2. I mean the first term was going to be 1, the difference was going to be 2. So the general formula will be Tn. This is the standard formula: a plus n minus 1 d. The first term will be 1 and the difference will be 2. Okay, so 1 times 2 times n is going to be 2n, and 1 times -1 times 2 It's going to be negative 2. Therefore, Tn will be 2n. 1 minus 2 is going to be minus 1. So that's how you can work with 1.3.5. Now at 1.3.6, we need to show that the formula is valid for row 5. The formula is valid for row 5, so that is 1.3.6. What we could do, since we need to see that the formula they said is valid, counting from the numbers that we had here, 1 2 3 4 5 6 7 8, okay, 1 2, okay, 3 here, 4 5 6 7 8 9 10. So the row 5 had, the first term in row 5 was 21. So in this case, using the formula that we have derived at 1.3.5, we will substitute T11 here. T11, sorry for that, 2 times 11, that's 22, and 22 T11 will be having 21, because 22 minus 1, that will be 22 minus 1, that will be 21, right? So now we are going to work with 1.3.7. So we need to show how this can be done in the same way. As we can see from row 3 is 27. So this was calculated as 3 times 7, which is 21, plus 2, which is 23, plus 4, that will be 27. Similarly as at row 4. So we need to show row 8 now, how they came up with 512. Right at the total of row 8, we were told that at row 8, remember, that is 1.3.8. At row 8, it should give us, at row 8, we should get 512. Okay, 512. So how can we work out that? I have to think about the factors. Let's think about 8 times 57. 8 times 57. That is 456, which is closer to 512. So remember that they started with 2, 4, then it's going 6, so we are going to say 8 and blah blah blah. Let's see how we can put that. Plus 2 plus 4 plus 6 plus 8 plus 10 plus 12. So there should be 8 then. We should have 8, right? Let me count. 1 2 3 4 5 6 7 8. Okay, it's fine. So let's add by 2. Plus 4 plus 6 plus 8 plus 10 plus 12 plus 14. Oh, we should add by 14 here, sorry for that. Plus 14, so that gives us 512. So definitely this is correct. It's correct though. Right, then let's go to 1.3.9. At 1.3.9, they said show algebraically the results of 1.3.4. You may recall at 1.3.4 we had a sum formula n all over 2, which is 2a. Oh, am I jumping? This was 1.3.7. Sorry for that. I definitely jumped. So we're supposed to go to 1.3.8. At 1.3.8, we have the sum of the first n consecutive number is given as n plus 1. Write down a formula for the first n minus 1 consecutive even number. First thing, we were given that the even consecutive, the sum of the even consecutive is given as n plus 1. We need to find Sn minus 1 in this case. So since they said n minus 1, the sum of the first n minus 1. Where there is n, we are going to put n minus 1, right? So in this case, it's going to be n minus 1 plus 1 So I was supposed to put bracket, but it's fine. We'll make it out. N minus 1, take out the bracket there. It's n minus 1 plus 1. Okay. N minus 1. Negative 1 plus 1, it's 0. So we are left with n. So in this case, we are going to have n times n, that will be n squared. N times negative 1, that will be n. So the sum of Sn minus 1 is given as n squared minus n, right? Then let's go to 1.3.9. At 1.3.9, show algebraically the result of 1.3 is given. Let's start with 1.3.4. They said at 1.3.4, you may recall that it was Sn to a plus n minus 1d. And they said it's given by using the result of 1.3.5. Right. You may recall that the result of 1.3.5 was given as 2n minus 1, right? And the result of what? 1.3.7. At 1.3.7, we were supposed to show that this is valid. Then we also have to use the result of 1. And the result of 1.3.8, okay, in which we got this at 1.3.8. So we need to show it algebraically. Okay, how can we work this? Using the sum formula, we know that this was derived by, let's say it was breaking like this. When we need to, let's break to a, it will be a plus n minus 1d. Where a plus n minus 1d is equals to the general term tn in this case. So we are given tn. What is tn? It's 2n minus 1, meaning that where there is a plus n minus 1d, we are going to place 2n minus 1, right? So that's how we can use the results of 1.3 and the results of 1.3.5. Already, we have already used the results of 1.3.7. Okay, all right. Okay. All right. So we also need to use the results of 1.3.8. If we use the result of 1.3.8, we're given the sum of Sn minus 1. So the sum was this, ne? Was Sn minus 1. Because both of them are the sum, I think we should equate them. Yes, in the easiest way will be equating them. Then that's how you can work out with 1.3.9. Yeah, 1.3.9 was quite tedious, but hope you find this video useful. Yes, you can continue further here. You can continue further by taking this equating. Yeah, the best way will be equating, because if we take this, if we put n minus 1 again here, I think the best way will be equating, so that we have already written it algebraically. So that's how you can work with question 1. Feel free to comment, and don't forget to subscribe, press the red button, and let's grow this channel. We love you.